It's me again. So what we're going to do for this video is we're going to identify which compound is oxidized or reduced, and as a bonus we're going to be also identifying which compound is the oxidizing agent, right? So this one has 4 parts to it, I believe, and it's number 35 on your homework for chapter 8 for my 101 class. So they give us a reaction to start off with, and they say which one's oxidized and which one's the oxidizing agent. So let's go ahead and just assign oxidation numbers to everything. Now, what thing do we ignore? We kind of ignore the coefficients when we're identifying oxidation numbers, right? So I have a rule for H and O. H in a molecular compound is going to be +1. O is going to be -2. And this has to total out to 0, correct? Because there's no charge on this. So H is going to bring a total +1. O is going to bring a total of -6. So what does N have to be to make this statement true? N has to be +5. All right. So in compound O, we have a rule for O. So he's going to be -2. This has to total out to 0. This is going to be -4, right? Totals out to 0 because there's no charge on SO2. So the oxidation numbers have to total out to 0. There's 2 of these oxygens, both of which carry a -2, so it's a total of -4. So sulfur must be +4. Now on the right-hand side, I have a rule for H and I have a rule for O, don't I? H will be +1. O will be -2. It all has to total out to 0 because there's no charge on H2SO4. There's 2 H's, so it's a +2, correct? And there are 4 oxygens, so it is a -8. So sulfur in this situation has to be a +6 to make it true. Then over here, in a molecular compound, NO2, there's no charge on NO2, so it has to equal 0. O's will be -2, and there's 2 of them, so -4. So N in this case has to be a +4. So N goes from +5 to +4, and sulfur goes from +4 to +6. So I can identify this here. Is this reduced or oxidized? So in this case, N goes from +5 to +4. Do you gain electrons to do that, or do you lose electrons to do that? You gain electrons to go from a +5 to a +4. So you gain electrons, so you are reduced. Therefore, you are the oxidizing agent. Correct? Now this situation, sulfur goes from a +4 to a +6. Do you gain electrons or lose electrons to become more positive? You have to lose electrons. So you lose electrons, so he is oxidized. ED, haha. So if you're oxidized, you are the reducing agent. So the question is, online, it asks, which one is oxidized? It says, what's the whole answer? It says, what substance is oxidized? You would type in the full formula SO2. You wouldn't just type the element SO2. Then it says, what's the oxidizing agent? You would type in the full formula HNO3. That may be tripping up some people. So I believe that this is part A and this is part B. So then we move on to part C. It's another example that I did not write out just yet, but it's CO2S3, 2 HBRs, become, maybe I should give myself some room to write, H2S, COS, and Br2. Okay. So we have to assign oxidation numbers to these, and this one's a little trickier, and I'm not even showing it. There we go. Sorry, guys. So this is part C. And when I said you have to write the full number, substance that's oxidized, SO2, and then what is the oxidizing agent, HNO3, you have to type those in as a full formula. So for part C, they give us this equation, and then they ask the same thing, what's oxidized and what's the oxidizing agent? So we have to assign oxidation numbers. So let's do the ones that are a little bit more obvious to us. How about for HBr? It has to total out to 0 because there's no charge. We know H is going to be +1, so we know Br is -1. For a total of +1 and -1, right? How about for Br2? That one's a little more obvious as well. He's by himself, so he's 0. So we know right away Br goes from -1 to 0. So something happens there, right? What else can we very easily assign oxidation numbers to? How about the H2S? We have a rule for H and we don't have a rule for S. So let's use our rule for H, which will be +1. There's 2 of them, so it's a total of +2, so S has to be, -2. Alright, so the ones that we don't really have rules for are cobalt and sulfur, right? Cobalt and sulfur are ones we don't really have rules for. I would not give you this on an exam, but cobalt is a transition metal, so since cobalt is a transition metal, it has more flexibility, if you will, on its charges and on its oxidation levels. So I'm probably going to assign the sulfur first. Remember how when we're assigning oxidation numbers, we go kind of in order of what we know for sure, what's likely, and then we determine it. Sulfur, if you look, sulfur is under oxygen, isn't it, in the periodic table? So sulfur usually has a charge of -2, correct? So its oxidation number will be -2. So this goes down to the same rule where, if you remember, it said monoatomic anions tend to have oxidation equal the charge. It's S, sulfur's by itself, so this is cobalt sulfide, so it's by itself. This is also cobalt sulfide, but what charge, right? What's the charge on cobalt? We have to determine that. So sulfur is going to carry a -2, so there's 3 of them, so total of -6. So cobalt has to bring a total of +6, but there's 2 of them, right? So each cobalt will be a +3. So cobalt's +3. This has to total out to 0, and we know sulfur's bringing a total of -6, so cobalt has to bring a total of +6, and there's 2 of them, so each one is +3. Over here, again, remember, we're ignoring the coefficients for the balanced reaction. Sulfur, we're going to assume, is a -2 as well. Everything has to total out to 0. We're going to assume sulfur is a -2, so cobalt in this case has to be a +2. So cobalt goes from +3 to +2, and bromine goes from -1 to 0. So these must be our compounds that change. So if this compound, cobalt goes from a +3 to a +2, do you gain electrons to do that, or do you lose electrons to do that? You have to gain electrons to go from a +3 to a +2. So this gained electrons, so it's reduced. So it must be the oxidizing agent, right? HBr, however, goes from a -1 to a 0, so he became more positive, didn't he? So how do you become more positive? You have to lose electrons. So you must be oxidized. And if you are oxidized, you are the reducing agent. Handwriting. So the question on your homework says, identify what substance is oxidized. That would be this substance. So what substance is oxidized? You would say the full formula is HBr. And then the next one says, what is the oxidizing agent? You would say CO subscript 2 S subscript 3. I do hope that helped, and I'm going to lower that a little bit. There we go. So that's how you would type in your answer. Alright guys, that is how you identify which compound in a formula is either being reduced or oxidized, and then you can then determine which one is the reducing agent or oxidizing agent. Bye!